back and forth. Okay, so that's the setup. So two gamblers, A and B, with the sequence, I'll call them round, to distinguish, I'm thinking of the word game as the entire process, and each round is one individual bet. Sequence of rounds where they bet $1 each time. Each round is independent. They're just a sequence of independent bets, $1 each time. And let's assume that P equals the probability that A wins a certain round. So for any particular round, the probability is P that A wins, and it's 1 minus P that B wins. And often in this class, we'll abbreviate 1 minus P to Q. So Q is the probability that B wins a round. P is the probability that A wins a round. Then they keep repeating that, either forever or until one of them goes broke. Okay, so that's the setup. And the problem is to find what's the probability that A wins the entire game. That is, that A wins all the money and B goes bankrupt. Okay? So that's the problem. So find the probability that A wins the entire game. So B is ruined, we would say. Or we could ask the other question, what's the probability that A gets ruined? Okay. But of course, if we can do one of those problems, we can do the other one in the same way. Okay? I'll put ruined in quotes. Ruined means bankruptcy. Now, we need to assume, what's the initial conditions. Assuming that A starts with I dollars and B starts with n minus I dollars, I chose the numbers, I chose the notation this way just so that, I is just makes me think of an integer because I'm assuming integer dollars going back and forth. And I call B's initial wealth n minus I because then the total is capital N dollars. So this is a closed system, right? No money is coming in or going out. So there's basically n dollars on the table that are just, going back and forth until one player has all of the capital N dollars. That's the total amount of wealth sitting on the table, right? That's being redistributed back and forth. Okay? So that's the setup of the problem.